All right, let's set the scene. It's your first cybersecurity internship, and boom, you get your first big project. Build a system that automatically hunts for security flaws. So, where do you even begin? Well, in this explainer, we're going to break down that exact challenge step by step and show you exactly how it's done.
This one sentence, it's the key to this whole thing. It's all about mixing two really powerful ideas. First, using automation to scan the systems you know you have. And second, using open source intelligence, or OSINT, to see your company from the outside, just like an attacker would. It's the only way to get the complete picture.
So yeah, picture it. It's your first week. Your mission, basically, is to become a digital detective. You're not just fetching coffee. You are on the front lines. Your job is to find the cracks in the armor before the bad guys do. This isn't just some intern project. It's a real deal defense mission.
So, what is this mission exactly? Let's dig into the challenge your manager has just dropped on your desk.
Okay, so the core task is to build a pipeline. Just think of it like an automated assembly line for security data. Every single night, it's going to wake up, automatically scan your company's stuff, take what it finds, add some more context, and then, this is the most important part, it prioritizes everything so the team knows exactly what to fix first.
And trust me, this is not just busy work. This is about stopping actual incidents before they happen. We're talking about finding that forgotten admin panel that someone left wide open to the internet. Or, finding a massive flaw like Log4Shell in a few hours instead of days. That kind of speed is literally the difference between being safe and being on the news.
Now, to build this pipeline, you need the right tools. And to pick the right tools, you first have to understand the two main ways you can even look for these vulnerabilities.
So on one side, you have your active scanners. This is your inside view. Tools like Nessus or Trivy, they scan the servers and apps you already know about, looking for known problems like missing patches. But then, on the other side, you have internet OSINT tools like Shodan and Census. This is the outside view. They look at your company from the public internet, and they often find things you didn't even know you had exposed. You absolutely need both, period.
All right, we get the mission. We know the tools. Now for the main event, actually building this thing. We're going to break it down into 4 super clear, manageable steps. Okay, step 1, you scan your known stuff to get a baseline. Step 2, you enrich that data. You ask, okay, what does a tool like Shodan know about these systems? This adds that crucial outside-in context. Step 3, and this is where the real magic happens, you prioritize. You write a script that looks not just at how severe a flaw is, but also how important the system is. A critical flaw on some test server isn't nearly as scary as a medium one on your main production database. And finally, step 4, you automate the whole shebang to run every night and filter out all the junk.
So you've built this awesome engine. It's running every night, collecting all this data. But, a pile of data is pretty useless on its own. So what's the final output? How do you turn all this technical jargon into something the team can actually use?
The ultimate goal is just clarity. You're taking this potentially massive, overwhelming list of findings and boiling it down into a simple, direct, prioritized to-do list. You're answering the one question everyone has: what do we need to fix right now?
And this is what it all boils down to. A clean, simple dashboard showing the top critical issues. Anyone, from an engineer to a manager, can look at this and instantly see the asset, the specific vulnerability, that's the CVEID, which just stands for Common Vulnerabilities and Exposures, and a clear score. It's actionable intelligence right there at a glance.
And here's another key output: tracking your progress. This simple little chart tells a really powerful story. Are we just finding new problems every week, or are old ones sticking around? See that high number of recurring findings? That might mean the team is having trouble actually fixing things. This is how you measure if your security program is actually getting better over time.
Okay, so let's step back for a second. By finishing this mission, you haven't just built a cool tool. You've picked up a whole set of skills that are, frankly, in huge demand all across the industry.
You've gotten real, hands-on experience with vulnerability automation and OSINT enrichment. You now know how to build real prioritization logic and think about designing remediation workflows. These aren't just buzzwords. They are the fundamental building blocks of pretty much any modern security team. In short, you've basically leveled up. You've earned yourself a new title: Exposure Discovery Engineer. You've proved you can build an automated system that blends inside and outside views to create intelligence your team can act on. That is a huge, huge accomplishment.
And we'll leave you with this final thought to chew on.
Your new pipeline is incredibly powerful, but that power can be a double-edged sword. It can find tons of stuff, but it can also just flood your team with alerts. So the next level challenge isn't just about finding everything. It's about finding the right things. How do you tune the system to find the signal in all that noise? That, right there, is the real art of cybersecurity engineering.